All right. So first two sections, I like to teach these two together because it's taking systems of linear equations and solving them in multiple ways. So systems of linear equations are equations that don't have exponents on the variables. Okay? It's linear because it doesn't have any exponents on the variables. So there are always three possible outcomes. The first outcome is the most common one that happens, more often than any other, is that there's one solution. That is also called consistent and independent. So if you had a coordinate plane and you had two graphs that were drawn on the same coordinate plane, where they cross, that point right there, that is that one solution. So this example of this, it's an ordered pair. That one solution is where those two graphs cross. We're going to find multiple ways how to find that point out of that. So we're looking for that ordered pair, that point where they cross. That's what we're going to be looking for. That one solution. That's the most common thing that's going to happen, is just getting one solution. The second outcome that could happen would be that there's no solution. Another name for no solution is an inconsistent system. The graph of an inconsistent system, guess how many times the lines touch? None. Those two lines are meant to be parallel. That means they never cross, they never touch. So parallel lines, there's no intersection. They never cross. So inconsistent system has no solutions. The lines never cross. Okay, we'll see. We're going to see that in algebra as well when we do this, solve these systems with different methods. The last option that can happen is what's called infinitely many solutions. The kind of formal name for that is consistent and dependent. Okay. Consistent means you have answers. Independent means you have one answer. Dependent means you have more than one answer. You actually have an infinite number of answers. What's going to happen there, the graph ends up being the same line right on top of one another. And I'm just drawing that line, and then I'll draw that blue line like right on top of it. Okay. So they're laying right on top of each other. They're touching each other in an infinite number of places. Okay. So that's what a consistent and dependent system looks like on the graph. So three outcomes. One solution, that's what's going to happen most of the time. No solution, that means we don't have answers. And infinitely many solutions means we've got so many answers we can't tell you what any of them are. Okay, what any single one is. There's just so many of them. Okay. Now we're going to solve those systems using different methods. Okay. The first method that we're going to talk about is substitution. Solving a system by substitution. So here's our first set of equations. 2x minus y equals 2. And then the second equation is y equals negative x minus 2. So there's a system of equations, and we're going to use substitution to solve that. So substitution tells us that we need to take something and substitute it into the other equation. So on this problem, we're going to take this stuff and we're going to substitute it in for y in that first equation. So that's going to be 2x minus parentheses negative x minus 2, and then that's equal to 2. So I've replaced y with what the second equation said y was equal to. Now I'm going to work that problem to find out what x is. So to work that problem, I'm going to follow order of operations. I'm going to get x by itself. I'm going to combine like terms. All of the same stuff we've done for years in solving an equation. So the first thing I'm going to do is I'm going to distribute this negative 1 to both of those things there and get 2x plus x plus 2 equals 2. And then I'm going to combine like terms. So that's going to give me 3x plus 2 is equal to 2. So I just put my like terms together there. That 1x and that 3x, 1x and 2x together gave me the 3x. That's what I did there. Now I'm going to try to get x by itself. That's the next step. So I'm going to move the 2 by subtraction. It's going to give me 3x is equal to 0. And then the last step is divide by that 3. 0 divided by 3 is going to be 0. So my x value is going to be 0. To find my y value, I can take that x value and go back into either one of these equations. It doesn't matter which one. You pick the one you like the best. I'm going to go to this one right here that has y by itself already and plug in 0 for x. So that's going to be y equals negative 1 times 0 minus 2. So that's going to be 0 minus 2, which is negative 2. So my ordered pair is 0, negative 2. That's using substitution to solve that system of equations. And that's one of those, because I got an x and a y value, that's one, it has one solution. That's what we found there. It has one solution. I found that one ordered pair where they cross. All right, let's do another one by substitution. Let's say we had 3x plus 2y equals 11. Negative x plus y equals positive 3. So that's our system, and I want to solve that using substitution. So to solve it using substitution, I need to get a variable by itself. And it doesn't matter which equation I get that from, but I want to try to do the easiest one possible. So the first one, I've got 3's and 2's by the x's. That's probably not going to be easy. Not near as easy as it would be to get x or y by itself in the second equation. So I'm going to get y by itself in the second equation. So I'm going to add x to both sides. That's going to give me y is equal to x plus 3. Then I'm going to take that stuff, and again, I'm going to substitute it back into the other equation. So I got to go back to the other equation, and I'm going to put that x plus 3 in the place of that y. Okay. Then I'm working that problem to get x by itself, get my like terms combined, all that fun stuff. Okay. So I'm going to distribute the 2. So that's going to give me 3x plus 2x plus 6 equals 11. And then 3x plus 2x is 5x equals 11. 5x plus 6 equals 11. What's the next step? Subtract 6, yes. So that's going to be 5x is equal to 5. One more step. Ooh, that works out nice. X is equal to positive 1. How do I find out what y is? Yeah, plug the 1 in for one of the x's. It doesn't matter which equation I go to. I can go to this very top one up here. I can go to the second one. I can even go to this one where I've got y equals. And that's the one I'd rather use just because the math's quicker and easier. I get done faster. Anytime I can get done faster, that's better. So I'm going to plug that in. Y equals 1 plus 3. So what is y? 4. So we have an ordered pair. 1, 4. The ordered pair is always X then Y. If it uses different letters, if it uses A and B, it's always in alphabetical order. Whatever letters they use, it's always in alphabetical order for the ordered pair. So those two equations that we started with, if we graphed them, they would cross at the ordered pair 1, 4. So that'd be up in the first quadrant there. Okay. So substitution, solving it, getting x by, or getting one of the letters, get one of the equations to have, get that letter by itself, substitute that stuff back in the other equation. The next method is my favorite way. Elimination. In this method, you want to look for equations that are in standard form. AX plus BY equals C. X and Y are on the same side. Okay, here's a system of equations that would be great for solving by elimination. The reason it would be great for solving by elimination is because you already have X and Y on the same side for both equations, and you have opposites on one of the letters. So the positive 3x on one equation, a negative 3x on the other equation. So all I'm going to do is I'm going to add these two equations together. 3x plus negative 3x, they cancel each other out or eliminate one another. That's the name of the game. And then negative 4 plus 6 is positive 2y. And then 1 plus 7 would be 8. So I'm just adding up the two equations, and it ends up eliminating the x's. So now I've got a one-step equation to solve to get what y is. So I divide by 2. Y is equal to 4. There's my y value. Now, with these, it really doesn't matter which one you go back into to plug in. Just pick one. I usually just go with the top one. That way I don't even have to think about it. So I'm just going to go 3x minus 4. And then instead of y, I'm putting that 4 that I found. And then I'm working this problem out. So that's going to be 3x minus 16 equals 1. And then I'm going to add 16. 3x is equal to 17. And then last, I would divide by 3. And I get a fraction answer, and that's okay. That happens. 17 over 3 is my x value. So my ordered pair is going to be 17 over 3, comma 4. There's my ordered pair. On that problem, elimination was great. We already had opposites on our letters. Sometimes you don't have the opposites on there to begin with, and you've got to make them show up. So let's look at one where we've got to do a little bit more work to get it to eliminate. So let's say we had 3x minus 4y equals 1, and then 2x plus 3y equals 12. So on this problem, it's already set up to where I think elimination would be a good method because it's got x and y on the same side for both equations. What we need to do is decide which one of those letters do I want to eliminate. Do I want to eliminate x's or do I want to eliminate y's? Honestly, it doesn't matter which one you do. You do the one you think is the easiest for you. For me, the easiest would be y's, because the 4 is already negative and the 3 on the y there is positive. I don't have to deal with adding a sign in there because they're already opposite signs. All I need to think of now is what number do 4 and 3 both go into? Not what number goes into them, but what number do they go into? 12, right? So I want to turn that 4y into a negative 12y. So I'm going to multiply this top equation. I'm going to multiply it by 3. The bottom equation, I'm going to multiply by 4. That'll turn that 3y into a positive 12y. That's going to convert this problem into 9x minus 12y is equal to 3. The second equation is going to convert into 8x plus 12y equals 48. Nope. 4 times 3 is 12. 4 times 12. Yeah, 4 times 12 is 48. Yeah, that's right. Now, I now have opposites on my y's. So I can add these two equations together. What happens to the y's? They're eliminated. What is 9x plus 8x? 17x. Positive 9 and positive 8 would be 17x. What's 48 plus 3? 51. We're adding those together. Now I got a one-stepper to get x by itself. Just divide by 17. X would be 3. Then I get to pick which problem I want to work with. It doesn't matter which one. You pick the one you think's the easiest, and I'm going to plug a 3 in for x and find out what y is. I'm going to go to the second one because it doesn't have any negatives. It really doesn't matter. I would go to the original just because the numbers are smaller. But you can do any of them. Any of those equations up there are fair game. I'm going to go to the originals because the numbers are smaller. So I'm going to go 2 times 3 plus 3y equals 12. I went into the second equation with that 3. That's going to give me 6 plus 3y is equal to 12. We'll subtract 6. 3y is equal to 6. Divide by 3. Y equals 2. So my ordered pair, 3, 2. So elimination works out really nice if you got x and y on the same side already. All right. Now let's look at it. Let's choose, or I'm just going to write the instructions as solve the system. I'm not going to say which way to do it. You choose. Because here's the great thing about solving systems. whether you do substitution, elimination, or a matrix that we'll do later, it doesn't matter. They all three get the same, all of the methods get the same answers. Okay? No matter which method you choose, you should get the same solutions. Okay? So let's look at this one. 8x minus 2y equals negative 4. Negative 4x plus y equals 2. All right. So let's pick a method. What method do you guys want to use to solve this? Say it again. Elimination. That's my favorite way. I'm good with that. So if we're going to use elimination, what letter are you going to eliminate? X or Y? Okay, so if we're going to eliminate X, what do I need to do? Yeah, you can multiply any of the equations by anything you need to, as long as you do the whole equation. You can't just do part of the equation, but if you do the whole thing, you can multiply any of them by whatever you want. So yeah, multiplying the top one by 1 and the bottom by 2 would work. Yeah. All right, so does multiplying by 1 do anything to it? No. So really, we're not really multiplying that top one by anything. So you don't have to. You look to see what you need to do. You could multiply both of them by something. In this case, we only need to multiply the bottom one by 2. And that's going to convert over to be negative 8x plus 2y equals positive 4. And here we have 8x minus 2y equals negative 4. So the top one didn't change. The bottom one did change. Now we go to add them together. What happens on this one? Yeah, the x's cancel out, and so do the y's. If everything cancels out, 0 is what's left. What's on the other side? Negative 4 plus 4 is 0. Does 0 equal 0? Yes. Because this is true, then this is an infinitely many solutions. Not always going to be the case. That actually is one of the rare things to happen, that you have infinitely many solutions. Okay? The most common thing is you have one solution. Infinitely many and no solutions are not very common. They don't happen a lot. But when you're doing substitution or elimination, if all of the variables cancel out and what you've got left is true, it's infinitely many. Okay? If what's left is true, 0 equals 0, if you had 7 equals 7 or something like that, and all the letters are gone, then it's infinitely many solutions. Let's look at this next example. Yes, ma'am. It would have done the same thing. Absolutely. It would end up with even like 0 to equal to 0 or 2 equals 2 or something like that. It would have done the same thing. Let's look at this example. Negative 2y plus 3x equals 4. Negative 6x plus 4y equals 7. They try to mess you up on this one. I'm going to rearrange the first equation because I need it in the same order as the second equation. So I just rearranged the first equation, didn't change the sign of anything, I just moved it. Where the x's were in front, the y's were second, and then what is equal to is on the right. Now, substitution or elimination, either one works well here. I would more likely go for elimination here because I've got numbers in front of the variables. Anytime I have numbers in front of the variables, that's the method I typically go for. So what do I need to do to eliminate either X or Y here? Multiply the top one by 2. That's going to give us 6X minus 4Y equals 8. And then we have negative 6X plus 4Y is equal to 7. When I add those two equations together, what happens? 0 is equal to 15. Does 0 ever equal 15? No, $0 is never equal to $15. So because this is false, this is a no solution or an inconsistent system. If the letters are still in there, then it's got an answer. If the letters get canceled out, then it's either a no solution or an infinitely many solutions. And it depends on what's left. If it's true, infinitely many. If it's false, no solution. Whether you do elimination or substitution, same rule. No solution. Another way of writing that would be a circle with a slash through it. They actually might even do this, the empty set. All of those mean no solution. Different ways of writing that. That empty set, the null set there, that circle with a slash through it, or that empty set right there, that's way back from the beginning of Math 100. Y'all remember doing set theory back in August of last fall? It's been a while, but they mean the same things. Okay. So far we've got substitution and elimination methods for solving a system of equations. The next thing that I want to talk about is same two sections, is solving using the graphing calculator and a matrix. Okay. So we're going to do using the TI-84 matrix row operations. There's 3 steps. Step 1, create an augmented matrix. Step 2, enter into the TI-84 and run RREF on that matrix. RREF stands for reduced row echelon form. Not that you have to know that, but it helps you, remember those letters. Reduced row echelon form is what that stands for. Okay. All right. Step 3, get solutions from the matrix. So here's our first system. 3x minus 4y equals 1. 5x plus 2y equals 19. Notice that system is written like you were going to do elimination. So if you're going to do the matrix method with the calculator, you want it set up like you're going to do elimination. So you want standard form on your equations. Set it up where x and y are on the same side of the equation. Okay. The augmented matrix. So this is what we got to know this. Because in the past, on the final exam, sometimes they would just give you a system and say, which one of these is the correct augmented matrix? The augmented matrix, put your little bracket. The first row is the first equation. Just take the letters out. 3, -4, 1. The second row is the second equation. Take the letters out. 5, 2, 19. That is the augmented matrix. It has 2 rows by 3 columns. Size is going to be important when we go to put this in the calculator, because we got to tell the calculator what size matrix we're putting in there. All right. Now we're ready to go to the calculator. Okay. So on my calculator, I'm on the regular calculator screen. I'm not graphing here. I'm on the regular calculator screen. I'm going to hit second and then the X inverse button. So it's highlighted in red there. So it's blue button and then the X inverse button. It's right beside the sign button. Second X inverse. And then I'm going to go over to edit. Then I'm going to hit enter on matrix A. Yours may have numbers and stuff in there. Yours may not. It's okay. We're going to fix everybody's to be the same. Okay. I'm on matrix A. At some point in life, I had some 3x4 matrix that I was doing. I'm going to do a 2x3. So I'm going to, right there where it says 3, where it's blinking, the cursor, I'm going to hit a 2, enter. And then where it says 4 and it's blinking there, I'm going to hit 3, enter. Notice how it resized it to the correct size. 2 rows by 3 columns. Now I want to enter that augmented matrix that we made up. Okay, so I'm going to put in my numbers. I've got 3, enter, -4, enter, 1, enter. Then it jumps me to the second row. I'm going to put in my coefficients for that one. It's 5, enter, 2, enter, 19, enter. Okay. So I put that matrix into my calculator. Everybody up with me on that? Now, I'm going to go back to the regular calculator screen. So to do that, I hit second mode, and that will get me out of the matrix menu and onto the regular calculator screen. Second, and then mode is right beside it. That gets you out of whatever you're in. Okay. Now I'm going to tell the calculator to do reduced row echelon form. So I'm going to hit second matrix again. This time I'm going to go over to math. So press the right arrow key. And there's a whole bunch of things the calculator will do with the matrix. We're looking for RREF. It's down toward the bottom. So scroll down to the bottom, toward the bottom there. And you're looking for RREF. Right there is RREF. Make sure it's the 2 R's. RREF. And hit enter. Now it says, okay, you want me to do reduced row echelon form on what? It asked me for a matrix there. So I'm going to tell it what matrix to use. So I'm going to hit second matrix again. And then I'm going to choose matrix A because that's where I put mine. Close the parentheses and hit enter. That matrix that we get back is the reduced row echelon form of that. So the after RREF, we're getting back this matrix 1, 0, 3, 0, 1, 3. What that tells us, this first row says X equals 3. The second row, that should be a 2 there. Sorry, I was saying it and writing it at the same time. I can't do that evidently. The second row says Y equals 2. If I look at my calculator, that's what I've got. The first row says 1X, no Y's is equal to 3. Second row says no X's, 1 Y is equal to 2. So it gets me the ordered pair 3, 2 as my solution. There's my ordered pair. If I had done that matrix with elimination or substitution, I get the same answer. Most of the time with two variable systems, I don't usually do a matrix because it takes me too long to type it in compared to just doing the elimination and being done. But it is a valid method. Let's look at one more of those. Let's say we had this system, 3x minus 5y equals 8, 2x plus 2y equals 5. There's our system. Let's solve that using a matrix. Three x minus 5y equals 8, 2x plus 2y equals 5. So we're going to put in a 2 by 3 matrix. 3, negative 5, 8, 2, 2, 5. And I'm going to run RREF. Not 2 F's. And that should give me a matrix that has 1, 0, 0, 1, and then some answers over there. So I'm going to go to my calculator. Second matrix. Go over to edit. 2 by 3. I have a 3, a negative 5, and an 8. 2, 2, 5. Second, quit. And then I'm going to tell it to do the reduced row echelon form of that matrix. So second matrix, over to math, find RREF. Second matrix A is where I put mine. Now I got decimals there. I want it in fraction form. So to get your calculator to change something from a decimal to a fraction, you hit math, enter, enter. And that'll change it into fraction form. So 41 over 16, negative 1 over 16. So that gets us x equals 41 over 16, y equals negative 1 over 16, or the ordered pair, 41 sixteenths, negative 1 sixteenths. So both of these examples had one solution. So they are consistent and independent because they have one solution. Let's do this system. X plus y equals 2. 2x plus 2y equals 5. Run that on a matrix and get the solutions. Your augmented matrix, 1, 1, 2, 2, 2, 5. Oh, why I put my 1 so close there? And then run RREF on that. Second matrix, over to edit, 2 by 3 again. So I'm just going to use matrix A again. 1, 1, 2, 2, 2, oops, 5. Then I'm going to run RREF. So go over to math, RREF, matrix A. This one doesn't look right. It has 1, 1, 0, 0, 0, 1. That bottom row is the one that tells us what's going on. That bottom row tells us that there's 0 x's and 0 y's, but it somehow adds up to be 1. How can 0 x's and 0 y's add up to be anything other than 0? Can they? No, if I have nothing plus nothing, I gotta, if it's right, I get nothing. In this case, I get something besides nothing. So that is a no solution problem. Because of that bottom row, it says that 0x's and 0y's is something other than 0. That tells me this is a no solution. Because of that bottom row. That's the reason it's no solution. Anytime you get all zeros and then something else over here on the end, all zeros and then something else, that's a no solution for using the matrix. Let's run it on this system. X plus y equals 2 again. But then now my new equation on the bottom is 3x plus 3y equals 6. Put that into a matrix and run your RREF on that. And let's see what we get. Second matrix, go to edit, 2 by 3, 1, 1, 2, 3, 3, 6. RREF again, matrix A again. The bottom row has all zeros in it. That bottom row, that's telling me that 0x's plus 0y's is equal to 0, which is always true. So we got all zeros on that bottom, so that's going to tell me that this is infinitely many solutions. The beautiful thing about all this is it doesn't matter which method you use, you're going to get the same answer if you do it correctly. So you can always check by doing a different method or by taking your answers and plugging them back into this system to see if they work. No matter which method you use, it works. The great thing about the matrix system is that you can do larger systems of equations, like this one, where you maybe have x minus y plus 5z equals negative 6, 3x plus 3y minus z equals 10, and x plus 3y plus 2z equals 5. So you have, in this case, we have 3 variables in our problem. The matrix method is the best way to solve these. They can be solved by substitution or elimination, but we're talking taking a whole page to do one problem, where the matrix method is the most efficient method for solving this. So when we put this into the calculator, what size is the augmented matrix going to be? 3 by 4. 3 rows, 4 columns. So you got 1, -1, 5. Then it's equal to -6. 3, 3, -1, 10. 1, 3, 2, 5. That is going to be my 3 by 4 matrix that I'm going to enter into the calculator. And then I'm going to run RREF on that. Second matrix, to edit, I'm going to change my matrix A to 3 by 4. And then I'm putting that in there. So 1, -1, 5, -6, 3, 3, -1, 10, 1, 3, 2, 5. And then I'm running RREF on that matrix. And there I have that reduced row echelon form. That first row is 1, 0, 0, 1. The second row is 0, 1, 0, 2. The third row, 0, 0, 1, negative 1. What that first row tells me is that x equals 1. The second row tells me y equals 2. The third row tells me that z is equal to negative 1. Okay? So 1x, no y's, no z's is equal to 1. No x's, 1y, no z's is equal to 2. That's y equals 2. No x's, no y's, 1z is equal to negative 1. So that's how I'm getting those. First row is x, second row is y, third row is z. The answers are written in what's called an ordered triple. X comes first, then y, then z. So for us, that would be 1, 2, negative 1. That's the ordered triple. 3 variable systems can also have no solution or infinitely many solutions. It's going to be the same look. Bottom row tells the tale. If it's all zeros and a 1, that's a no solution. If it's all zeros and a 0, if everything in the bottom row is a 0, that's an infinitely many. So 3 variable systems, that's about as big as they get in Math 110. You can go much larger. NASA uses systems that are way larger than that because they've got so many more variables to deal with that. They use computer systems to help them solve them. You ever seen the movie Hidden Figures? There's a movie about this lady. I can't remember the girl's name. Kevin Costner's in the movie, and there's a lady in NASA before they converted over all these computer systems. They had people that their job was a calculator. Like they manually did the math by hand. And but anyway, in that they're solving matrices or big equation sets like this. And the computer, they started. This is when they first started going over the computer. The computer only had enough memory to go so many decimal places, but the calculators, the people that were actually doing the math, they could go as many decimal places as they wanted to. If you round off a little too early, and you miss your landing spot by quite a bit out of that. And they discovered that in that movie. It's pretty cool thing. But anyway, a matrix, very, very versatile use for solving systems of equations. Okay, so, I probably did. I've shown it several times. It's a great movie. I like it. It's a pretty decent movie. All right, so systems of equations that are linear. That means no exponents on the variables. That's when you can use the matrix. That's the only time you can use the matrix. Linear systems, no exponents on the variables. Now, last section of the night. Section 5.5. Non-linear systems. Non-linear systems mean systems that do have exponents on the variables, or they're not perfectly linear. Could be absolute value graphs, could be quadratics, could be lines, but they're mixed together. These, we're going to use the substitution and elimination methods to solve. So that's why we really went over those methods. I would expect most of us to do the matrix to solve linear systems. Here is a nonlinear system. What makes this nonlinear is the fact that this problem, the first one, has x squared in it. That's not a straight line. X squared is a parabola. So that's a nonlinear system. It's something that's not a straight line. Okay? So in this problem, you could do elimination, you can do substitution. Either method works really good. I'm going to do elimination because look at the y's. I got a negative y and I got a positive y. Looking for those things are the clues to being able to solve these. So you've got to do elimination or substitution here to solve this. I'm going to do elimination, and I'm going to eliminate the y's because one's a negative y and the other one's a positive y. They cancel each other out. If I add these equations together, those cancel each other out. On the right-hand side, what is 4 plus negative 2? Positive 2. On the left-hand side, this is where folks get lost. Can you add x squared plus x and get one thing? No, they're not like terms, are they? So we're going to write that down as x squared plus x. Because they are not like terms. That's what changes this from the linear systems. The fact that, hey, those two don't go together like if it were both plain x's. Now we've got a quadratic to solve. So this is where we got to go back and drag out some of the old laundry that we had from back in earlier in the semester, and some of it from fall semester too. Okay, so we've got to pull out some skills. So if I'm going to solve a quadratic, what do I need to get the equation equal to? 0. So I'm going to move this 2 by subtraction. So that's going to give me x squared plus x minus 2 equals 0. And then I have options for solving that. One way is by factoring. Multiply to be negative 2, add to be positive 1. What multiplies to be negative 2 and adds to be positive 1? 2 times negative 1. Very good. And because it has the 1 in front of the x squared, I can take my shortcut on my factoring and get x plus 2, x minus 1 equals 0. Then I'm going to take each factor and set it equal to 0 and get x by itself. Minus 2. So that's going to be x equals negative 2. Add 1. It's going to be x equals 1. I have two x values. I need to find the y values that go with each of those. Okay? So those are my x answers. To find the y answers, I go back to my original equations. Go back to the originals. It doesn't matter which one you go back to. I'm going to go back to the second one. I'm going to use x plus y equals negative 2. And I'm going to plug in x equals negative 2. That's going to be negative 2 plus y is equal to negative 2. I'm going to add 2. What's y equal there? 0. So that one is going to give me the ordered pair, negative 2, 0. Then I'm going to go over here and I'm going to do the problem when x equals 1. 1 plus y equals negative 2. I'm going to solve that. Subtract 1. Y equals negative 3. What is my ordered pair? 1, negative 3. I found the two solutions. The reason there are two solutions is because this quadratic looks like that. The linear looks like that. How many places are those two crossing? 2. Got two answers. A parabola and a line can cross in two places. Linear equations, you only have one solution. No solutions are infinitely many. Nonlinears, you have more than one sometimes, not always. Okay. Now, let's take that same system and I'm going to show you a way to use the calculator to help you solve it. Okay? Same system, same example, but I'm going to use the calculator. So I have x squared minus y is equal to 4. X plus y equals negative 2. Same equation set. What I'm going to do, I'm I'm going to use the TI-84. Number one, I'm going to get y by itself. For each equation. Number two, I'm going to graph. Okay, so let's do that. Let's do those two things. Okay. So first equation, what do I do to get y by itself? I'm going to subtract x squared. That's going to give me negative y equals negative x squared plus 4. Y is not completely by itself yet. What do I need to do? Divide by negative 1. So everybody gets divided by negative 1. So y is equal to x squared minus 4. That's one of my equations I'm going to graph. I'm going to go ahead and graph it. Go to y equals on my calculator. I'm going to hit x squared minus 4. Hit graph. I'm going to have to reset my window. Zoom 6 resets your window. Sure, I got the right equation. I do. So there's my parabola, the first equation. Now I'm going to take my second equation and I'm going to get y by itself. Subtract x. And there it is. Y equals negative x minus 2. I'm going to graph that. So I'm going to go to my calculator and we'll hit y equals negative x minus 2. Hit graph. All right. Now, do we see them crossing in two places? Yes. Now, here's where we got to get the calculator to tell us where those are. Okay. So to get the calculator to do that, step 3 is we're going to hit second and then trace. We want the intersect. So on the calculator, I'm hitting second, trace. Intersect is option 5. All right. Now, it's going to ask for two things. It's going to ask for first curve and second curve. All you got to do is hit enter on first curve. Second curve, hit enter. On the guess, this is where you got to move. Okay. We want to move close to the one we want. I've got two of them. It doesn't matter which one I get first. I'm going to move to this one over on the left first. So I'm going to take my cursor and I'm going to move to the left when it says guess. I don't have to be right on it. I just got to be close to it. I'm going to hit enter. It finds the intersection that's closest to your cursor. Negative 2, 0. Isn't that what we found when we did it with algebra? Yes. Now I'm going to find the other one. So I'm going to hit second, trace, go to intersect. First curve, hit enter. Second curve, hit enter. Guess, move over there by the one you want. I don't have to be right on it, just need to be somewhat close to it. There it is, positive 1, negative 3. That's the same two answers we found when we did it with algebra. Both methods, perfectly valid way of solving these equations. Okay? Algebra can get kind of tough. Graphing, if you can learn this method, you can get some solutions with that. But you got to be able to see where they're crossing on the screen for this to work. Okay? All right, so I'm gonna put a note here. First curve, hit enter. Second curve, hit enter. On the guess, move toward the intersection you want. Then enter. It will find the one that's closest to your cursor. All right, let's do another one. Let's do a totally different one. Let's see here. Try to get a good one here. Let's say we had, example C, x squared plus y equals 8. Then x plus 3y equals 0. X squared plus y is equal to 8, and x plus 3y is equal to 0. This one would be a great candidate for graphing. So I'm going to get y by itself on both of these. So that's going to be y equals negative x squared plus 8. I'm going to get this one. I'm going to move the x. 3y is equal to negative x. Divide by 3. Y is equal to negative 1/3 x. Okay. Now I'm going to graph those. So y equals, got negative x squared plus 8. And then this one, I've got negative 1/3. So I'm going to hit alpha y equals, get my fraction button, negative 1/3. Press the right arrow key and put the x beside that. Hit graph. All right, I see them crossing in 2 places. So that means I'm going to get 2 answers out of this. Looks like one of them's kind of at a in-between spot, so that's okay. We can get a decimal answer, not a problem. And then one of them, it looks like it's close to a good spot. I don't know if it's exactly on it, but it's real close. So I'm going to find those. So what do I press to find those intersections? Second trace, go down there to intersect. What do I do for first curve? Enter. Second curve. Now, on the guess, where do I go? Whichever one you want to find first. It doesn't matter. I'm going to go to that left one first. I'm left-handed, so that's where I go first usually. I'm closer to that point than I am the other one, so I'm going to hit enter. There's me a decimal approximation for that. So about negative 2.67 and positive 0.89. Negative 2.67, positive 0.89. That's one solution. Let's find the other solution. How do I do it? Second trace, intersect, enter for first curve, enter for second curve, and then move over there close to that other one. I think it's about at 3, negative 1, but it may not be exactly on that. Ooh, it is exactly on that. 3, negative 1. There's my 2 solutions. Okay. All right. Let's look at one where graphing probably isn't the best idea. And I'll explain to you why it's not. Okay. x squared plus y squared equals 4. 2x squared minus y squared equals 8. Now, the reason that I would tell you that this is not a good candidate for graphing is because both variables have exponents. That's when it's not a good idea to graph. Because it's going to be so cumbersome to get your calculator to graph both of those, you're going to end up having to graph like 4 different equations to do that. So this is one of those where it's not ideal to graph it. But they always leave you a nice way on problems like this. The nice way is elimination on a problem like this. Notice the first equation has a positive y squared and the second equation has a negative y squared. Positive y squared and a negative y squared. Those are opposites of one another. So elimination would be the best method on this one. So I'm going to eliminate the y squareds. Okay? So I'm just going to add these two equations together, and y squared cancels out negative y squared. What is 1x squared plus 2x squared? Those are like terms, aren't they? So that's 3x squared. What is 8 plus 4? 12. All right, I've got an equation that only has x in it. It's got x squared in it, but it's only an x. There's no y's or anything else going on. Now all I have to do is solve that equation to get my x answers. So what can I do to get x by itself here? Divide by 3. That gets us x squared is equal to 12 divided by 3 would be 4. And then we're going to take the square root. Anytime I bring the square root to the game, I've got to bring a plus or minus with me. So what is the square root of 4? It's plus or minus 2. So I get two answers here. I get x equals positive 2. I get x equals negative 2. That's what I've gotten there. Two different answers for x. Now I got to get two different answers for y. So I'm going to take that and plug it into one of those equations. It doesn't matter which one. You pick your favorite. I'm going to pick the first one because it's got less work to do. It has ones in front of x squared and y squared, so that's less work. So I'm going to plug in the 2 in for x there. 2 squared plus y squared is equal to 4. So that's going to be 4 plus y squared is equal to 4. Then I'm going to subtract 4. Ooh, this is going to work out beautifully. Y squared is equal to 0, and then I take the square root, and y is equal to 0. Because 0 doesn't have plus or minus, right? It's just 0. So I have an ordered pair there. I have the ordered pair 2, 0. I'm going to do the same thing, but with a negative 2. When I square negative 2, what do I get? What's negative 2 times negative 2? Positive 4. And hey, this is going to work out very similar. Y squared is equal to 0. Oh, we'll take the square root. Y is equal to 0 again. So I have an ordered pair negative 2, 0. I found the two solutions to my system of nonlinear equations. So if there's an elimination that can happen, that's a good method for solving. Yes, ma'am. Mm-hmm. All right. You probably typed it in like this, which your calculator reads as square the 2, then make it negative. You need parentheses around your negative 2. That anytime you square anything that's not an imaginary number, it should be positive when you get done. I'm glad you noticed that, though, because that's an important thing. Okay. So look for places, if it's got more than one variable squared or with an exponent on it, that's when graphing really isn't your best friend. If it doesn't have more than one variable with an exponent on it, graphing is really a great method for solving these. Okay. If it does have more than one variable with an exponent, then that's where the elimination or substitution is your best method. Okay. All right. Earliest night we've had in a long time. That is all of this section. Okay. Chapter 5, 5.1, 5.2 quizzes will be due next on Sunday night. 5.3 or 5.5, excuse me, will be Sunday night as well. So that's 5.5 is the nonlinear. 5.1 and 5.2 is the linear systems, substitution, elimination, matrix. Okay. Monday we'll have labs over these things, and then last lectures of the semester over matrix things, more stuff with matrices. So that last few sections is not hard at all. Okay. I hope you have a good week.